Hi guys, in this section we are discussing about hydrogen peroxide gas plasma sterilization. Hi guys, today I'm here to teach you about hydrogen peroxide gas plasma sterilization. So you might be wondering, is hydrogen peroxide is only used in gas plasma sterilization? No, it's not like that. We can use oxygen, hydrogen and hydrogen peroxide too. So we are mainly discussing about hydrogen peroxide gas plasma sterilization just because we are having this topic in our syllabus, OTT syllabus. So let's go through the topic. So you might be wondering what is gas plasma and what is plasma. So plasma, it is the fourth state of matter. You know, the other states of matter are solid, liquid or gases, and the fourth state of matter is plasma. So plasma is the fourth state of matter and it contains a balanced amount of positively or negatively charged particles. So it is an ionized gas. Ionized gas means it is an electrized gas. It contains charges. You know, it is ionized means contains charged particles. So it is charged, and it is already told it is the first state of matter, and it is the main important point of plasma. So it is divided into two categories: high temperature and low temperature. And for the natural example of high temperature is lightning, and the low temperature in this plasma sterilization we are using the low temperature sterilization method, just because mainly we are using gas plasma sterilization for those instruments which cannot withstand high temperature. So we are mainly using hydrogen peroxide, low temperature hydrogen peroxide for this gas plasma sterilization. And ethylene oxide sterilization, you know, ethylene oxide sterilization I will describe about it in another class. Ethylene oxide sterilization, we are replacing ethylene oxide sterilization with this gas plasma sterilization just because it is toxic free. That's why we are using hydrogen peroxide gas plasma. So let's go through some deep points. So already told introduction of gas plasma. Plasma is the fourth state of matter and it contains positively and negatively charged ion particles. It is an ionized gas and it can be categorized into two types: high temperature and low temperature. So in this method we are mainly using low temperature. Not only mainly, we are using only low temperature sterilization method just because we are in the sterilizing instruments that cannot withstand high temperatures. Okay. So let's go step by step, like we write in exams. First of all, mainly in previous year question papers, we are having it 5 mark questions as hydrogen peroxide gas plasma sterilization, or 3 marks. So for our main principle or main aim of writing in exams, we have to write mainly about sterilization, right? So let's go through it. First, we should write the introduction as I taught, and second, you should write about the uses of which instruments can be sterilized by hydrogen peroxide gas plasma sterilization. So instruments that can be sterilized by gas plasma sterilization are electrocautery instruments. You might be wondering what is electrocautery instruments. Once you have gone posting, you might know that it is diathermy instrument. And electrical devices, many electrical devices we can use, and corrosion susceptible metals, and then in kind of vascular instruments or spine sets. So instruments that can be sterilized by gas plasma are electrocautery devices, spine sets, electrical devices, or all instruments that cannot withstand high temperatures, like in ophthalmic surgeries, ophthalmic surgery instruments cannot withstand high temperatures. So mainly ophthalmic instruments are sterilized by gas plasma sterilization. So the next point you should write where it is application of this gas plasma sterilization, that means where it is used. So first, it is used in mainly it is household. In household we can use it in hospitals, and then dental clinics, and then some electrical shops to clean the electrical devices. We are using gas plasma sterilization. So there is a special device to done this gas plasma sterilization, and thus that instrument is known as plasma sterilizer. So plasma sterilizer is a special device used for doing the gas plasma sterilization. Sorry, I missed a very important topic. History of plasma, that means who invented it and who got patented it, like that. So plasma was invented by Sir William Crookes in 1879. It was not known plasma until 1928. Sir Irving Langmuir coined the term plasma. Plasma means formed or molded. So until 1928, plasma is not as is not known as plasma. Sir Irving Langmuir give this name plasma, invention done by Sir William Crookes, and it was patented in and it was first introduced towards end of 1960s and patented in 1987. So gas plasma sterilization. Gas plasma is affected. The factors affecting the gas plasma are the choice of gas, as I already told. We cannot not only use hydrogen peroxide in gas plasma. We can use oxygen, hydrogen, carbon dioxide, or any kind of air we can use in gas plasma sterilization. But in this method, we are using hydrogen peroxide because choice of gas is very important. And the second one is gas flow rate. Gas flow rate is also very important. And then packaging, quantity of the material, gas pressure. We don't need that much depth of these things just because we are writing it in about 5 marks or 3 marks, that's all. And then so plasma sterilization, it operates via 3 mechanisms. First one, it is the free radical radiation. Second one, UV, VUV. And UV, we all know what is UV, it is ultraviolet rays. What is VUV means vacuum ultraviolet rays. And volatilize, the third step is volatilization. We can go one by one. Before this, we can go through the steps or mechanisms of this gas plasma sterilization. Mainly it is divided into 4 phases. First phase is the vacuum phase, the second phase is the injection phase, the third phase is the gas plasma phase, and the fourth phase is the vent phase. Okay. So the first phase is vacuum phase, which means we already told that gas plasma sterilization is done with a device known as gas plasma sterilizer, and the chamber is evacuated. That is vacuum phase. The chamber is we are evacuating the chamber. So in this vacuum phase, we are evacuating all the air inside the chamber. That is the vacuum phase, and the second phase is the injection phase. In this injection phase, in this phase, we are using a concentration of 6 mg per liter of hydrogen peroxide Sterling, and we are injecting it to the chamber. Okay, and this hydrogen peroxide gets vaporized in this chamber. And the third phase is sorry, I missed a step, and there is a step also known as diffusion phase. Okay, diffusion phase, and in this diffusion phase, the hydrogen peroxide vapor diffuses through almost all the items placed in this chamber. So it penetrates through almost all the instruments and inside the chambers and all. And the fourth step is gas plasma phase. So we are applying an electrical field to this chamber to create that gas plasma state. So in this gas plasma phase state, we are creating gas plasma mode there. So we are applying an electrical field to there. In this method, the hydrogen peroxide breaks into, like water breaks down into hydrogen and oxygen. In this method, hydrogen peroxide is breaking into hydroxyl and hydroperoxyl group, that is OH. Hydroxyl group already know OH, and hydroperoxyl OH2. Okay, which initiate the microbial inactivation. In this method, gas plasma base, it is the important method, and it is the important phase. In this phase, a vacuum phase is created. A gas plasma state is created by applying an electrical field, and in this method, microbial inactivation takes place. So, and the last step is vent phase. The vent meaning is removal. So we are removing all the gases inside it, like removal of excess gas. If there is excess gas, we are removing that excess gas. And so in this method, byproducts are gaining. Byproducts are water vapor, oxygen, and these are really non-toxic, and it is very environmental friendly and non-toxic. And that's all the phases of mechanism of gas plasma sterilization. First one is the vacuum phase. We are creating a vacuum state. Second one is the injection phase. We are introducing a concentration of 6 mg per liter hydrogen peroxide Sterling to it. And the third phase is the diffusion phase. All this hydrogen peroxide Sterling is diffusing through all these chambers. And the fourth phase is the gas plasma phase. In this gas plasma phase, the hydrogen peroxide is breaking down into OH and HO2, that is hydroxyl and hydroperoxyl group. And the last and final phase is the vent phase, which means removal of excess gas in this phase. Okay. So as I already told, the byproducts are really non-toxic, that is water vapors, water and all. So the main advantage is it is environmental friendly, pollution free, and it can be used in house control, and it is economically friendly. So if you and it is somewhat costly. So if you, and then it has high sterilization efficiency. And so disadvantage, in this hydrogen peroxide gas plasma sterilization, disadvantage is very low. First disadvantage, not sterilize liquids, powders, etc. So it is a major fallback. And then it is highly costly. So we are using it for low temperature. So high temperature materials cannot be sterilized using this method, and liquids, powders cannot be sterilized using gas plasma sterilization, and it is somewhat costly. That's all the disadvantages of this sterilization. And we are for sterilization control. You might be wondering, what is sterilization control? Sterilization controls are some bacteria we are using for that sterilization method. And in this method, we are using spores of Bacillus stereothermophilus and Bacillus subtilis. So we are using the spores of these two bacteria. So I missed a very important topic, that is the mechanisms. In this mechanism, UV VUV radiation is a very important step. So in this UV VUV radiation, you might be wondering, I already told what is VUV. VUV means vacuum ultraviolet. So in this method, electron ions plus ion bombardments plus thermal effects and the production and the local exposure of the ultraviolet radiation, all this combines to disrupt the cell membrane of the DNA, and it causes denature of the protein and the damage of the bacterial DNA. And in this method, in the bacterial DNA, it forms thymine dimers which inhibit the bacterial replication and base damage, and finally the DNA strand breaks. So this method is very important. This is the most important mechanism, UV VUV radiation method. And we told this is a cycle. In this cycle, the cycle is about 75 minutes. That's all about hydrogen peroxide gas plasma sterilization. And any doubts, you can ask in comment section. And so I'll be sharing notes.